if I was going to keep that in mind, I mean, we can use only the default login data method as a return method, okay? So I didn't have to do it this way. I could have done it just with the return new list, but then instead of login list, I need to use the default login data, okay? So again, the course assumes some development knowledge, but I will try to explain things as simple as possible so that you understand them. Now, the condition logic comes in, and I will say the following. If string equals, I'm using already built functionality in C#. If the username equals to the one from the login list, right? From this one, okay? And I would say the string equals, and if the passwords are the same, right? And if the passwords are the same, then what? Then return true, okay? Because this method returns ball, right? Okay. Else return false. Okay, that would mean that otherwise the actually credentials are not right, or if none of it is actually met, if none of the above conditions are met, then return false. Okay, so we are done actually with our logged mechanism at this point. But this one is protected method, right? Let's sort of build an access method now for this one as well. All right. It's very simple to do these things once you get to understand what we are really doing. Correct? Okay. And there we go. So I'm going to do a public bool right here. And I will say get login info information, right? Get login information. And I will what? Pass in the string, the username and the password. I will just use short names right here. And I will return what? I will return the information from the method logged by passing in the username and the password. Right? Simple as that. It's very simple, isn't it? So, okay, this, all right. Check if supplied the username and password exists. If yes, log in. If not, can't log in. Okay. Basically, if yes, return true. If not, return false. All right. So one other thing that we mentioned right here is that I promised you that we're going to be using design patterns, right? And that we will be building actually this backend system just the way we're supposed to do it, so that it's very easy maintainable and so that other developers could understand what we're doing, and the logic is better, obviously. So we're going to use the solid principles right here, and that means that okay, what we need to do, I will start first of all with the actually incorporating interfaces for every and each class, okay, and so basically get the idea of how this of what needs to be really done there. Okay, so why a solid principle? I already said actually about the solid principle. A solid principle is really nothing really new on the in the software engineering actually area. But the solid principles are 5 principles of object-oriented class design. Okay, so just keep that in mind, and basically This is a design pattern that every modern developer should know at this point. These solid principles are brought to us developers by the person that's famous among the programming circles as Uncle Bob, and that's been brought to us back in 2000. And so basically, and then later on, actually, the principles were introduced by Michael others. Okay, just keep that in mind. And the solid actually principles, the solid thing stand is it's an acronym, and so basically every and each letter says something. Or for example, letter S is the it includes the single responsibility principle. The letter O includes the discusses the open close principle. Letter L is a Liskov substitution principle. Letter I is the interface segregation principle, and letter D is the dependency inversion principle. So basically, at this point, I've already actually the single responsibility principle states that a class should do only one thing, and therefore it should only have a single reason to change, right? I mean, you see how basically our classes are the class is already actually, you see how this login class does only one thing right here. The login as well is being it's already actually also does only one thing right here. Okay, and then we need the interface segregation principle. And how do we fulfill this one? We extract an interface of the basically of the class itself, and there we go. So let me just show you how this looks like now. Okay, there we go. So we have a, so basically, I mean, when a newcomer or another programmer comes in and looks at our solution, he will look at probably the interfaces first to try to understand actually what we have under the class login. Because imagine, for example, login details is a little bit longer class right now. Imagine if we had like 1,000 lines of code right here, the developer would go nuts, right? I mean, in order for him to understand actually what's going on. But if we had interface extracted, for example, from the class itself, things would have been much easier. Now let me show you how the log details look like. So basically, this tells me that okay, so there is a one collection of a login list, all right. So we are expecting something right here, and then there is a bool method which gets the login information, and we're passing something, right?